Hello, and welcome to the IoT Chat, where we explore the latest development in the Internet of Things. I'm your host, Christina Cardoza, Associate Editorial Director of Insight.Tech. And today, we're talking about industrial device communications with a panel of experts from B&R Automation, ABB, the OPC Foundation, and Intel. But before we jump into the conversation, let's get to know our guests. Peter Lutz from the OPC Foundation, I'll start with you. Please tell us more about yourself and the company.
Yeah, so I'm Peter Lutz. I'm responsible for the so-called field-level communications initiative of the OPC Foundation. We take care of extensions for OPC-UA to bring OPC-UA to the field level. A few words maybe about the OPC Foundation. This is a non-profit organization developing specifications for the industry. We have currently more than 880 members, including all the big names in IT and OT. And we are then submitting our specs to international standardization bodies such as IEC.
Great. Looking forward to hearing more about the foundation and your efforts in the industrial space. Stefan Schrödinger from B&R Automation, please tell us more about yourself and B&R.
Yes, hello everyone, and thanks Christina for having me on this panel today. My name is Stefan Schrödinger, and I'm heading the PLC and industrial communication business at B&R. And B&R is a global company, part of the ABB group, and primarily serving the OEM machinery market with leading-edge automation solutions.
Great, and we'll move to ABB next. We have Bernard Escherman. Bernard, welcome to the show.
Yeah, thanks a lot, Christina. Yeah, I'm Bernard Escherman. I'm with ABB, as you already explained. ABB, as a global engineering and technology company, probably doesn't need a big introduction. And I'm the CTO of Process Automation, which is one of the 4 global businesses of ABB dealing with the automation, electrification, and digitalization of industries that produce stuff that you don't measure in the number of pieces. That's the discrete automation that more Stefan would deal with, but in liters, kilograms, kilowatt hours, cubic meters, and so on. And I've been the CTO for a number of years in ABB Process Automation. I'm also responsible for the process automation products and platforms we have. And on the group level in ABB, I lead the overall technology team as the so-called Primus inter pares. And the link to the OPC Foundation is that obviously the OPC Foundation has a lot of companies that are members, and I represent ABB on the board of the OPC Foundation.
Great. And last but not least, David McCall from Intel. David, thanks for joining us today.
Thanks for having me. Lovely to be here. I'm Senior Director of Industrial Standards at Intel. I think Intel needs very little introduction, although most people, or some people, may not be familiar with our involvement in the industrial space. We have a thriving industrial PC business. We're also seeing a lot of transformation potential there as more compute gets applied to the industrial processes. And we shift from being a more hardware-focused business to a more software-focused ecosystem. So I'm involved in part of that and trying to make sure that the right standards are in place to enable that transformation and also apply some of our expertise from other fields into the industrial space.
Well, great to have you all joining today. The reason why we wanted to put together such a panel of experts is over the last couple of years, the manufacturing and industrial space has transformed tremendously. We have more devices connected to the internet and to each other than ever before, more sensors and data coming. And so that has caused some complications for manufacturers. So Stefan, I want to start with you and really set the stage for this conversation. What are the biggest challenges you and your company have been seeing on the factory floor today?
I think, first of all, it's actually not us that face the challenges, it's our customers. And if we look on our customer sides, and then we mentioned in the intro that we talk about the world which claims to be in the middle of an era of IoT, then I would, and basically our customers would argue that's not yet the case. And just taking a couple of examples, we have devices in a manufacturing plant talking to each other, if at all, and not at all considering security. And we know about security and the number of security threats we are facing in our world, and manufacturing specifically is heavily exposed to that. and not considering security, I would say, is really the first pain we see what our customers are facing today. Second, I mentioned not every device is talking to each other. And again, when we talk about IoT, and we still have a tremendous amount of equipment that's actually not yet talking to each other. That might be for the fact that we have equipment out there that doesn't have yet the capability to exchange data. But even more so, we have an issue of a very heterogeneous world of equipment coming from different vendors, and different vendors using different standards, primarily proprietary standards. And that's, again, something which really hinders the introduction of advanced analytics, of data really being transferred and converted into value. And OPC UA and TSN would really be the answer to tackle those questions. And last but not least, we also need to make sure that data can be interpreted without reading a 100 or 1,000 page handbook to know what's actually behind the bits and bytes that's transferred over the wires. And again, here OPC UA and the semantics that are associated with it is really the answer what our customers are looking for.
Absolutely. And it sounds like there are a wealth of challenges and complexities in today's smart factory and industry 4.0. So Bernard, I'm wondering if you can expand on some of the challenges Stefan just mentioned and, explain why it has been so challenging or hard to get these devices to communicate to each other, to collect all the data, and to really add the security aspect into everything.
Yeah, I guess a lot of that problem goes back to history, because in the past, multiple communication standards for these so-called field buses were developed by different companies, and none of the companies that developed a particular standard wanted to give it up. And even after moving to Ethernet as a predominant lower layer protocol, there are still multiple standards for the layers above, for example, to provide deterministic periodic communication of real-time data. And I always compare this with trying to build railway lines between two cities. Instead of building one big railway line, which would be the most efficient way to get fast trains from A to B, we've had multiple lines that are all slower. And with this new standard that the whole industry seems to embrace now, finally, we should get to something that actually gets us this one very fast railway line. Another challenge is that we don't have consistent information models for data when it moves from the instruments where something is measured through the automation and the edge to central servers and the cloud. And OPC UA actually provides a way to have consistent information models between all of these different layers, so that we don't have the translation effort and loss of information in between the different layers. So all of that is very important to making the world of communication change dramatically in the future.
Absolutely. And you and Stefan have teased a little bit of what we're going to get into today's conversation is the OPC Foundation and the OPC UA and other standards out there. But before we get into that, we're talking about all these challenges and complexities, and some may be wondering that it might be too much effort, it might be too much risk than the effort is worth with adding all of these devices. But these new technologies like the Internet of Things and AI are really benefiting the manufacturing space and the factory floor. So David, I'm wondering, since Intel has been such a leader in some of these digital technologies that the manufacturing industry is adding, if you could talk a little bit about the benefits of them, but also, the challenges to industrial communications adding them in.
Sure. So as we just heard, right now, the industrial comms tends to mean wired. It's deterministic because there's some level of mission criticality involved, whether that's tight timing requirements or need for high reliability or both. And the networking layer is tightly tied into an industrial automation protocol that runs over it. So if you've got one automation protocol, that means one network, and you can have trouble getting the data out from that little confined ecosystem. You've got those two drivers you mentioned, the IoT in general, and then specifically AI and machine vision, which I would sort of put together. IoT generally means more devices, which means more connectivity. Not all of that is probably going to be mission critical. Some of it will be, but not all of it. And not all of it's going to be wired in the long run either. We're expecting to see some of those wireless technologies, whether it's Wi-Fi or 5G, coming in initially in those non-mission critical areas where you're adding some safety requirements or some monitoring, and just getting those deployed quickly and cheaply, because running cables is expensive, is where wireless can bring in a real benefit. But also those wireless technologies are adding in their own deterministic capabilities. So they will become part of the production line and those mission critical control loops as well in the longer term. Then you've got the AI, machine vision. Those are workloads that ingest just huge quantities of data. Most of those are currently running in the data center, which because of the deterministic challenges means they're maybe not timing critical, but we can see huge opportunities for applying those technologies to those mission critical, timing critical loads. So you're blending and blurring the lines a bit between what is traditionally thought of as an IT technologies and OT technology. So long term, we're looking at having a single deterministic network which spans both wired and wireless technologies. And the workloads can just take the appropriate path. You'll deploy the right technologies in the right places, and this will all be a homogeneous and network that any protocol can take advantage of. But that's a huge amount of work. You're absolutely right that that is a huge effort. And to do that for every single automation protocol that's out there right now just doesn't seem feasible, which is one of the reasons we have for trying to make sure that this is all going to work over one network, so that at that lower layer, we're just going to be putting in that huge amount of effort once, and then everybody can use it. So big transitions are coming. You're just starting to see the beginnings of it right now, but we're working diligently, the companies on this call and others, to make sure that we've got the standards in place. And obviously that's what I'm mostly working on, to make sure we support that transition across the whole ecosystem.
Great. And the good news is there are efforts being made to address these challenges and complexities. So Peter, from the OPC Foundation, what can you tell us about the work that you've been doing with the organization and the standards playing a role to address these challenges?
Yeah, so Stefan and Bernhard already mentioned some of the key features and benefits of OPC UA. So maybe I can give a quick summary of what is so special about OPC UA. It's what we call an industrial framework to support interoperability. And this includes the built-in security mechanisms. It includes mechanisms to do information modeling, which is then driving also the common semantics, to have really semantics that are absolutely vendor neutral and vendor independent. And we are working actually on extensions on the one hand side for enhancing cloud connectivity, but also bringing OPC UA to the field for the different requirements we have, for example, deterministic communication, motion control, instrumentation, and not to forget functional safety. And with these extensions, we actually are able to establish OPC UA as a really fully scalable industrial communication solution that is fully scaling from the field to the cloud, and also, so to say, vice versa, or also horizontally. So between controllers, between field devices, between edge devices, or even between cloud systems.
Great. And as part of the field device challenges, I believe the standard from the OPC Foundation is the OPC-FX. So what can you tell us more about the work going on in that standard and where it is today?
Right. So OPC UA-FX is the term we use for the extensions to the OPC UA framework to cover the various use cases in the field level. So this is including, for example, controller-to-controller communications, but also then controller-to-field device, including field device-to-field device communications. And this is very important to understand that we are not creating a new generation of technology, but we really are basing the solution on the existing OPC UA framework. So all the companies supporting OPC UA today can easily, let's say, migrate or upgrade their products or applications to also support then the extensions for field level. And how we are doing this is we use different mappings to underlying transport protocols and physical layers. This is then very use case specific. So if we talk about communication to the cloud, we use MQTT. If we communicate in the field, we use, for example, UDP-IP.
Great. And some of the standards manufacturers have already started leveraging. So when we talk about all these challenges and complexities, Bernard, I'm wondering if you can expand on the benefits that you see your customers see once they start utilizing OPC Foundation and the various standards like the OPC UA and the coming FX.
Yeah, if we start on the lower level and we take, for example, OPC-FX using TSN as the lower layer communication protocol, obviously you've got the benefit that you can mix various types of traffic, non-deterministic, event-based traffic, and deterministic real-time traffic on a single communication medium. Which, for example, in our case means that for connecting the control room to cameras in the field, to sensors in the field, to actuators in the field, can all be done over the same communication medium without actually requiring separate wiring. If you look at connecting devices that need to be powered over the network, we've got a standard called APL, Advanced Physical Layer, coming that allows to provide both communication to instruments as well as the power to instruments over a special variant of Ethernet. And again, we can have OPC UA on top of it. And obviously, if we have this OPC UA layer throughout the system on different physical layers, on different transport protocols, that means that the interpretation of data stays the same throughout the system and you don't need to have any translations. It also stays the same no matter from which particular supplier, particular equipment that is involved in all of this comes. And that obviously is a large benefit in terms of the engineering that would be needed otherwise. So it helps the customers because they can connect anything to anything. It helps us because it reduces the efforts on our side for developing all kinds of different mappings and adapters.
That sounds great for customers. Taking advantage of OPC UA, it solves a lot of the headache and challenges that they're facing today. But I know, like David mentioned, this is a challenging effort. So I know it takes a lot of partners in the ecosystem to really make it possible, to really make standards like this make a dent in some of the issues we're seeing today. So Stefan, I'm wondering if you can talk about why you joined the OPC Foundation to work on these standards and how you're working with other partners in the ecosystem to address industrial communications.
I think referring to what Bernhard has said, I can only copy that. And if you summarize all the benefits that have been mentioned, in my opinion, there is only one way forward, and that is all about adopting open standards, enabling open ecosystems, go towards security. So from that point of view, we could make the answer very simple. There was no other choice. And I would even see whoever would not take that path, either from a supplier point of view, like automation equipment, like we are, but also from a sensor equipment, but also from companies producing edge equipment or other backend systems, cloud systems that play in the field of manufacturing. Not adopting open standards is a dead-end road. So taking that, I think to stay on a competitive level, OPC UA, FX, TSN, OPC UA in general, is really the only way to go. Look maybe a step further into the future, going towards more autonomous systems. Again, you can't manually interpret data. You can't push data over gateways and still hope that the semantics haven't been changed. Autonomous systems will will require autonomously working analytical paradigms. And again, you will end up with capabilities that are only provided by OPC UA and FX. So from this point of view, that's the only way to go.
And it's great to see, a technology giant like Intel involved in the OPC Foundation and these standards, because I think it really helps others in the industry see OPC Foundation, OPC UA, and the OPC-FX standards as legitimate standards that they should be also applying in their factory. So, David, I'm wondering if you can tell us more about Intel's involvement in the foundation and the standards and why you decided to help support this initiative.
Sure. Well, I already talked about how we have this vision of more software-defined architecture coming into the industrial ecosystem, more of these advanced workloads. And we've just been hearing about some of the problems that we can see that could act as barriers to the adoption of those sorts of approaches. And we saw OPC, and particularly the UA-FX extension of turning what was an existing the UA technology into a true field bus, as being a key way to overcome some of those barriers. So we wanted to get involved and to make sure that that is a really strong, viable standard, not just at the technology level, but at the business level, certification, all the other things that go together to make a truly interoperable ecosystem. And we can then take that and then show these use cases working in the real world. So we can put together demonstrators and be right there at the cutting edge, because that's where we do see OPC UA-FX as being. It's leading the way and showing how you can put together the technologies that are going to be absolutely critical in the next 5 to 10 years.
And I would love to hear from Peter's side what the importance has been for the OPC Foundation to work with Intel and BNR and ABB, as well as how you get other companies to work together on promoting this standard.
Yeah, so it's, I think, important to understand that the OPC Foundation is elaborating the specifications together with member companies of the OPC Foundation. So for this, we have different working groups set up. And here we heavily rely on the expertise and the know-how which comes in from these automation players like BNR and ABB, but also technology providers such as Intel. The good thing is that we have, let's say, all the big support from OT as well as from IT companies already as a given. So the good thing is we need not convince anyone, because there is broad support. All the big names in automation have committed to support the OPC UA-FX as extensions for OPC UA. That means certainly as soon as the specifications are available, we have then also the small and medium enterprises that are building their products upon OPC. But this is, let's say, as a given, because the whole industry is relying on OPC UA. So this is easy for us.
So what can we expect next from the OPC Foundation? What standards are you going to be working to bring out next? Or, how are you going to work in the future to improve these standards even further?
So certainly we are continuously improving our specs. And this, as I said before, it's a framework. So we are working on different elements, on different levels or layers, you could say. And I think Bernhard was mentioning some of the key technologies that are really elementary for the further success of OPC UA to cover all the requirements. So one key technology is certainly TSN, because it provides to us the deterministic transport and also is key for the IT-OT convergence. But in addition, especially for the process industry, the combination with the advanced physical layer, Ethernet APL, is highly relevant, because by bringing Ethernet to the field in these more critical applications in the hazardous areas, we open also the door for bringing in OPC UA and OPC UA-FX in all these field devices. But it's difficult to highlight a specific, let's say, extension or development. As I said, we're also working on cloud connectivity. So overall, we have a big framework and multiple working groups. So we are continuously improving and updating to the needs of the industry.
Don't forget 5G, Peter, because obviously once we have a deterministic wireless connectivity protocol, that's of course also a good base for OPC.
Thanks for the hint, Bernhard. Absolutely, yeah. This is why we already demonstrated that OPC-UA and OPC-FX also works over wireless connectivity. So I picked out maybe the two most important ones for the moment. What wireless connectivity is for sure very important, not only 5G, but also Wi-Fi 6, Wi-Fi 7 support. So this is the good thing with OPC, that it's transport agnostic, and we can so easily adapt to all the different standards that are relevant for industrial communication.
Well, I'm excited to see how else the OPC Foundation and, BNR Automation, ABB, and Intel work to improve, the manufacturing industry and really make us a smarter manufacturing, bring us into that industry 4.0 truly. And it seems like we've only just scratched the surface of this conversation. We could go in even deeper, but unfortunately we are running out of time. So before we go, I just want to throw it back to each and every one of you to, any final key thoughts or takeaways you want to leave our listeners with today, as well as where you expect the future of industrial communications will go and how your organization will be a part of it. So David, I will start with you.
I think what Peter made the point that OPC has really succeeded in making itself the de facto future for the industry. The only question is now about how quickly is that transition going to happen? I think if you go back a few years, there was maybe some questions about whether some of the bigger players would really embrace the OPC UA-FX direction. I think that's very clearly changed. And we see that all of the major vendors are looking to support their own existing protocols plus UA-FX. So UA-FX will gradually become sort of the lingua franca of IoT right down at the control level. It already is mostly that going up to the cloud. All the major cloud vendors, they're all standardizing on OPC UA for that sort of communication. So yeah, it's the network, I think, is going to be shared by multiple protocols, but OPC UA-FX is going to be right there at the cutting edge, and then gradually, particularly in greenfield sites, and then gradually more and more across brownfield sites, it's going to become the de facto communication protocol.
And that's probably a whole nother conversation in itself, the greenfield versus brownfield, efforts. But Stefan, before we go, is there anything else you wanted to add or any final key takeaways you wanted to leave listeners with?
Well, yes, I try again to put myself in the point of view of customers. And I think if all you would like to do is to run a factory, then at the end, the last thing you want to do is talk about details such as industrial communications and how I can connect one device with the other from different vendors. So from that point of view, I can only encourage the market, the operators of factories or the producers of equipment, of assets, to really start adopting OPC UA, because that is the answer. If you just want to focus on the efficiency and on the output and on the maybe adaptability of your factory and of your production line, then OPC UA is the answer to afterwards don't have to spend anymore any thoughts and any concerns on industrial communication.
Great. And Bernhard, where do you think this is all going? How is ABB going to be a part of it? Or, what do you hope the listeners get out of this conversation today?
Well, there's no question that ABB will be a part of it. We've been strongly driving the whole effort. But I guess what people should actually look at is everybody talks about the world being driven by data. And the main thing this is about is that any data created anywhere in an industrial plant shall be available with the needed quality of service to any place where it's needed. And that basically without communication engineering. And what we should actually think much more about is how can we get value out of the wealth of data that is available in the various factories and plants around the world in order to improve the efficiency, in order to improve the energy efficiency, which is, of course, nowadays a very important question, in order to improve the productivity of these plants and apply all of these techniques that typically are not running in the instrument itself, but possibly at the edge or in the cloud, like machine learning from all of these data. And so I'm convinced that the world will benefit a lot, not from the communication standard by itself, but also from being able to make much more use of the data that is already available. And as a final thought, there are lots of places where competition makes sense. For example, about how to use that data to create useful insights. But competition, in my view, doesn't make sense in developing competing communication standards that are all doing the same thing. That's not a useful way of having competition. The competition should be on more valuable things than that.
Absolutely. And it's great to see all of you come together on this standard to make it possible and to sort of eliminate those competing efforts out there. And since the large conversation has been around OPC Foundation and the standards you're working on, Peter, I will end with you. Any final key thoughts or takeaways you want to leave us with today?
Yeah, a lot has been said already, but maybe just from my personal perspective, I'm absolutely convinced that OPC UA, especially with the extensions we are currently working on for field level, will become the dominating industrial communication standard also for the field level. And for me, it's let's say two aspects to this. On the one hand side, I believe with the framework, with the strict layering, with the flexibility and all the features that OPC UA is providing, it's from a technical perspective, let's say the future-proof solution. And the only solution that is actually really scaling what I mentioned before, fully scaling from the field to the cloud, which no other communication solution can provide today. But the second aspect is more on the big support. As we have all the big players supporting it, it's becoming the standard just because of the broad acceptance and because OPC UA was always considered to be somehow what I typically call the neutral ground, not doing, as Bernhard mentioned, a competition on the communication interfaces and the communication solutions, but take competition out of that. And I think this is finally the success formula for broad adoption of OPC UA across all the different levels.
So for our listeners today and any organizations who want to learn more about the OPC Foundation, get involved, or learn more about the standards going on within the organization, where should they look to get that information? How can they get involved?
So certainly OPC Foundation homepage is an excellent entry point to learn more about the technology and all the activities going on. But certainly membership is certainly important because as a member, you can become more closer involved, even signing up for the different working groups. But just learning about OPC UA and the different flavors and use cases, also the YouTube channel of OPC Foundation is, I think, an excellent entry point. Listening to the experts explaining the technical concepts and also the benefits is for sure helpful.
Absolutely. Well, with that, I want to thank all of you for joining the podcast today. And thanks to our listeners for tuning in. If you like this episode, please subscribe, rate, review, like all of the above on your favorite streaming platform. And until next time, this has been the IoT Chat.